Welcome to the Weekly Squeak, your weekly geeky squeak with me, as always, Chris Chinchilla. I hope you're all well and safe and healthy. Things here in Berlin are returning slowly to a semblance of normality. I suppose it depends what your normal was. Hope others of you in the world are experiencing some similar positive changes and you're well. I don't have many links this week. I've just actually been, I've just been busy with work maybe, or not finding anything very interesting. I only have 3 links, but I have a good interview in the latter part of the show with Dale Kim from Hazelcast. And Hazelcast is an in-memory database for very high-performance processing of certain sorts of data. And we had a good chat a little while back, and I'm working my way through my backlog right now. So I look forward to that shortly. All right, I have a couple of very local links to share with you. I think we're all getting quite local right now, but I'm going to open with something quite international. So this is an article from Simon Pitt on 10. No more free lunch. Working at a tech company will never be the same. I think this is interesting in a couple of different ways. We are seeing a lot of the big players in the tech world collapsing somewhat right now. And I use the term tech loosely. Sometimes I think this is important to bear in mind. Things like WeWork, Uber, Airbnb, they're sort of tech companies. I wouldn't classify them as tech companies, actually. Shall we say big flying startups, maybe, is a better term to actually use. But they were all somewhat dependent on in-person, and they're obviously finding it hard to keep up. But I think it probably also highlights, and I've seen this happening with many big and small businesses in the past couple of months, that it's highlighting problems they probably already had, and thus then having an extended period of no income, but with lots of outgoings is mean that it's highlighting and breaking for them those business models that hadn't quite proved themselves yet. So I guess this article highlights that for that perspective, but also for hygiene perspectives, many things will change. We're already seeing companies that were not necessarily opposed to remote working, but were reluctant to do it fully, saying that's now okay. Free lunches, I guess, from the money reason, but also the health reason of people sharing food, maybe less common. Although, I don't know, I feel like there's some easy-ish resolutions to that. And new technology emerging in offices to handle these sorts of things, distance counters, people counters, not sort of automatically opening windows, all sorts of random things like that. I mean, hey, the coffee machine, you need automation on the coffee machine, maybe. I don't know. I feel like sometimes there's simpler solutions to some of these problems, like using hand sanitizer before you use the coffee machine or washing hands, something like that. Feels like a simpler solution, maybe. Maybe a cheaper one, at least in the short term, which hopefully this will be relevant for. So I don't know. We'll see. But the offices will change, maybe. I still wonder if a lot of the changes will be short-term. It depends, really. I suppose it depends what those changes are. And then especially it starts to reopen questions that people were already having about the effectiveness of open offices. Open offices have been complained about for some time anyway, and now we will see that they're potentially more problematic for health. So if we start putting up cubicles again, even if they're temporary, we start almost going back to where we were before. And some people celebrate that and others won't. But yeah, things will change. Things will change, at least for the short term. And what will they be? I'd actually love to hear some of your thoughts on this too. I mean, it doesn't really affect me so much. I haven't actually worked in an office with people in a convention office for some time. So it's hard for me to even remember what some of those things might have been. But we definitely have all sat there in offices with people all the time and stuff like that, and sneezing and things and thinking, oh my God. So yeah, in some ways there will be some positives in encouraging people to be more hygienic and things like that in the long run. So we'll see. We'll see. Have a look and let me know what you think. Next, on the subject of things changing, this is actually fresh off the press, as it were. I was in a press conference for IFA, Berlin's sort of consumer electronics show, like CES here in Europe, and the press conference finished just a couple of hours ago. And contrary to what a lot of people may have expected, they are not cancelling their show this year. They are not even going fully remote. What they are doing instead is offering a stripped down and optimized version of the in-person event plus virtual events for other people And it was actually quite an interesting press conference. They were very professional about it. They were very balanced and pragmatic about it, very sort of traditional German way. People asked them about how much money they're losing, and they said, and whether you're skeptical or realistic about this, who knows, that the money wasn't the important issue. They wanted to keep going with things and not just cancel. I'm not sure if that's strictly true or not. Who knows? But I can't imagine they will make a lot from the event they're planning. They're planning an event that will be kind of smaller and shorter, and it won't be open to the public. It will only be open to vendors, to industry, and to press. I'm not 100% sure if that will include me, because I think I was probably always on the lower echelons of their press access. And to be blunt, I write about such a small minority of IFA content. I don't know if it'd be worth it for me to go, for them or for me. But also local, so that might be a positive. It might be interesting to see how they handle it. Some of the details were a little unclear, whether there'd be booths or not. Of course, who can attend, who will even want to attend is also unclear. But still, I am quite pleased to see that instead of just cancelling, they are trying and seeing what they can do. And based on the current numbers in Berlin, which are reasonably low, and they are using very conservative numbers they will allow each day, so a maximum of 1,000 people, when actually the Berlin Senate has said to them by that point it will probably be up to 5,000, but they're allowing for a big bandwidth. And then supplementing that with remote interactions that are yet to be seen. And of course, the cost to people for exhibiting, probably not for attending, if it's all industry and press, is yet to be seen as well. And if it will be successful. But I like the idea they're at least thinking about it and thinking of trying, and maybe setting a blueprint for what in-person events can be like for the short to medium term. And I've been thinking this myself for some time. In fact, I wrote an article for D-Zone a little while back covering this topic, actually right at the beginning of all this, about that hybrid events may be the future. So, for example, take something like F8 or WWDC, where already people meet for kind of watch parties. And I think that may become a more common thing to do, a sort of meetup of meetups. Anyway, interesting stuff. I obviously will have to wait a little while to see how well it works. I think September, but I like the fact they're trying. And finally getting hyper-local here, but I think it's going to be affecting people on a global scale, but this is just to a local article. This is actually from a magazine here in Berlin called Ex-Berliner, an English magazine here in Berlin, by Matt Unicombe, about restaurants, or no, reopening might push some Berlin restaurants over the edge. And I also saw a comment today in the news that restaurants in their first week of being able to be open again were disappointed with the amount of people who came. I heard also secondhand from a restaurateur similar things. They were saying that the restrictions they have in place versus the amount of people they can have and the amount of staff they have to hire to enforce the regulations, it's not going to be worth it to a lot of them. They're actually going to probably be losing money. They probably, ironically, would make more money from government funding to be closed instead. But I think the government has the argument of you have to get things back, and the government wants to start getting taxes and things like that instead of just handing out money. The coffers need to be refilled, I suppose. And as you may or may not know, here in Berlin, a lot of the hospitality industry is running often on a razor edge profit anyway, because people want things cheap and aren't necessarily willing to pay good money for certain things. Let's not dig into that right now and any criticisms you may have of that statement, but it's kind of something that is mostly true. It's changing a little bit, but the vast majority of restaurants tend to focus on cheap and good value as opposed to high quality service or food. And then that does mean that those restaurants, but also the ones that are probably in higher rent areas and operating more high end, are also, for different reasons, operating on razor thin margins. And so they probably never had a lot of money in the bank anyway. So having an extended period of making no money plus an extended period of making little money, it is going to force a lot of places out. I've already seen some places closing. And what that will mean in the long run, who knows? Some of the positives could be that in the long run, of course, it might relieve pressure on commercial rents. And when things come back to quote unquote more normal, rents are lower, so new businesses can open. Who knows? That obviously is pure conjecture. But yeah, so there's not been a rush of people going out to support businesses. I mean, I've actually been trying. I'm kind of all for letting businesses try and do what they can within reason and within regulation. But I can't eat meals out 3 times a day. I think there's a lot of people still working from home, which means they don't feel like going out for lunch. I'm actually kind of the opposite if I work from home, to be honest with you. People have got into a habit now. I think people used to associate having lunch with around work, and breaking that habit was difficult in the first place, and now getting back to it again is equally as difficult. But I did have lunch in a restaurant yesterday, and it was quite nice to do it. That mental break from work I really missed, actually. And there's definitely a culture of doing that here. It's not common in every country, so maybe this doesn't seem that unusual to you. I know the UK, for example, people tended to grab lunch very quickly and go back to their desks, which I always found kind of unhealthy. So ironically, it's almost the reverse now. But I do miss that mental break. So let's see. Hopefully, all these places manage to hold in and keep just going for as long as possible, and then can get back to doing normal business at some point soon. But yeah, lots of uncertainty in all sectors, but that one especially. I think they've been some of the hardest hit in the short term anyway. So yeah, interesting times as always. All right, I hope you enjoyed my brief roundup of links, and now here is my interview with Dale Kim of Hazelcast.
My name is Dale Kim, so I'm the Senior Director of Technical Solutions here at Hazelcast. So I'm responsible for go-to-market and product strategy for the technologies that we build. And Hazelcast has its roots in in-memory data grids, which is one way that you can take advantage of memory across a cluster of computers. And we've since expanded that. So we're more broadly an in-memory computing platform that is all about gaining performance for your custom applications, as well as some of the applications you have in place.
So to people who may not know what that means, what does in-memory computing mean as opposed to, I guess, non-memory in-memory computing?
Yeah, so that's a great question. So in-memory simply means that you don't spill data onto disk. So you fully leverage the RAM so that you don't have the latencies that you normally get as a result of writing to either a spindle-based disk or to solid-state drives. So as most people know, that RAM accesses are far faster than other types of media. That's where you get the advantage for your applications.
Actually, because this is something I heard, and it was a sort of surprise to me when I heard it, that there is a significant, a noticeable speed difference between in RAM and SSD. I think a lot of people thought it would be very similar, but is it a difference of quite magnitude, or is it more of a technical speed difference because it's kind of already loaded by the operating system and things like that?
Yeah, so there are a number of things that try to narrow that gap, but there still is a significant difference between, and we're talking about orders of magnitude difference in terms of latency between solid state drives and memory. So we're talking about memory accesses to being in the multiple gigabytes of data per second, whereas some of the higher speed non-volatile RAM modules available will get into the low gigabytes, and that's why we were really important for some of our customers in industries like financial services, where they need that ultra fast ability, and storing it in memory is the only way that it makes sense.
Okay. You mentioned one particular business there that uses this kind of setup, but are there any others as well that rely on that speed boost is so necessary that it's worth it?
Yeah, and there are verticals that care about that, like telecommunications, like the entire retail industry. A lot of technology companies rely on it. And what we're seeing is that a lot of times it's not only the huge performance gains that they need, but it's the ability to scale out once you have something in place and you're looking to do more innovative things with the technology. For example, if we look at a broad use case like machine learning, or maybe to be a little bit more specific, fraud detection, you might run a single fraud detection algorithm and it might give you a decent level of accuracy. But we're finding that customers are running multiple algorithms in production in parallel to try to get a composite score that helps to better identify what is fraudulent. And as you probably know, fraud detection isn't just a simple binary decision. There's the notion of finding what is fraudulent, but also making sure that you don't have too many false positives, because that will hurt you as a company, mostly in terms of losing out on revenue as a result of the transaction fees. So being able to be more accurate with some of the calculations that you make as a result of running multiple algorithms in parallel is something that needs performance. And a lot of people might dismiss that as, well, I can't get that extra performance unless I put a lot of investment into my hardware. So it's not a route or an option for us. Whereas by leveraging software like Hazelcast, the use of in-memory and the use of speeds can be fully justified because of the actual, top and bottom line gains from having these more accurate calculations.
And is in-memory computing anything new? I get the feeling it might be one of these buzzwords that has sort of come back into favor, but is probably not necessarily a new thing. Is that wrong or right?
You're absolutely right. So in-memory computing has been around for a long time. And one thing that has held back from people fully adopting it is simply the cost of RAM. So while RAM is so much faster than SSDs, the cost is quite a bit more as well. So there is a bit of a trade-off and a sliding scale there. And we continually hear about the dropping prices of RAM, and only till recent times are customers seeing, or companies in general seeing, that now for some of their use cases, it absolutely makes sense to make the investment in RAM because the ROI is there. And then we're working with companies like Intel who have come up with new technologies that help drop prices even further. So you might have heard of Intel's Optane technology, which is a new way of storing data in memory. It'll look like either persistent RAM or volatile RAM, but the underlying technology is quite a bit different in terms of not using transistors. And it's a very, very interesting technological advance. But that helps to lower the costs of volatile RAM usage and can help more companies get involved with these higher speeds and this greater ability to do more work in the same amount of time.
I'm actually not familiar with that. Can you explain any more, or is what you said already kind of enough without going into a crazy amount of detail?
Yeah, there's some really fascinating, gory details behind it, but you can just think of it at a higher level that Optane is a technology that can be used in one of two ways. One, as an alternative to solid state drives, or as an alternative to dynamic RAM. And so with that capability, you can have either a very fast SSD, or you can have volatile RAM that's almost as fast as dynamic RAM, and in many cases just as fast, but for half the cost. And if you can see price drops in the volatile RAM area that significant, then I think suddenly the notion of in-memory computing becomes an obvious choice for a lot of companies.
And I mean, for the average kind of desktop user, you're probably looking at somewhere between 8 and 64 gig of RAM, usually. It's a fairly large range, but I would imagine that even that is probably not quite enough for most of these use cases, or maybe it is. Like, how much RAM are you usually using in a server or in a virtual machine on top of a server, etc.?
Yeah, we're actually dealing with clusters of computers.
Okay.
So one thing that we enable is tying together multiple servers so that they have a scalable and shared pool of RAM that can be used by these enterprise applications. So when you think about fraud detection or payment processing or even running chatbots in an artificial intelligence type of environment, you're going to need hundreds of gigabytes of data that includes customer data, new transactions, and any business data that helps with some of the calculations that you're running. So this is necessarily about huge allocations of RAM that are required for these enterprise applications, typically in a mission critical or business critical environment.
Okay. And are these similar to servers that people might be using in quote unquote traditional cluster/cloud computing, or are they different, or they're just configured differently? Is there much overlap between them and more normal, shall we say, clusters?
So from a cluster standpoint and an implementation standpoint, yes, it'll look like any other distributed system where you'll have these multiple instances, or on premises, you might have multiple nodes that are connected together with some underlying software. The difference of what we provide is the management of the memory. So you might build an application that can run on top of a distributed database, but that doesn't necessarily take advantage of all the RAM that you have. It tries to be very efficient about it because it relies more on disk. Whereas we're about being very efficient about the RAM usage so that you get that faster speed.
So quickly to fill in on that before we dive into what Hazelcast actually offers. So in theory, I could run any sort of normal cluster-friendly database on top of an in-memory cluster and it would work. It just may not necessarily see the benefits so much.
Well, you can see those as two separate things. So you can think of the database as the large-scale storage, and then you can plant an in-memory technology next to it and use that in one instance as a cache. So any of the frequently accessed data will be immediately available as RAM. So they're very complementary in that sense. And there are other opportunities for building custom applications that are purely in memory that you can build, and in a way, sometimes eliminate the database as being part of the critical path of your application processing.
Let's have a look at the products that you have, or the software that you have. The first I can see is Hazelcast IMDG, which I think is mostly what we've been talking about.
Correct.
IMDG, I'm guessing, standing for In-Memory Data Grid.
Correct.
How does that compare to, say, for someone coming from a more traditional data store? How does it compare, and what's kind of the learning curve of a developer or an implementer getting used to using it instead or alongside
An in-memory data grid looks very much like a database and has a lot of the similar concepts in terms of holding data for you and giving it to you when it's available. And the difference is around the programming model. So where databases, you generally process some small set of data, some subset of the data that you have. You might read it from the database, do some processing, and write it back. So it's more about storage, whereas an IMDG is more about the processing. So it's more about pushing the ability to parallelize your applications and handle all your data at once. And the comparison, the description I like to use is, imagine you're running an application on your desktop, and like you said, you might have perhaps 64 gigabytes of data. What if you suddenly have 500 gigabytes of data available at your disposal and you didn't have to do anything to add that? You just automatically got it. And that's what an IMDG does for you. It allows you to continue with the programming model that you're accustomed to, using your variables and accessing data. But at the same time, because of the backend distribution capabilities, data objects are swapped between the different servers in your cluster. So it looks like your computer that you're running on suddenly has a lot more RAM than it actually physically has.
And actually, I can see an image here that alludes to some of what we've discussed. So you have your clients going into the Hazelcast cluster and then out the other side to traditional RDMSs, Mongo, Cassandra, etc. I just wondered, this might be where it's been a little bit of time since I've developed applications that needed this, but is it comparable to something like Redis or something like that? Or am I not quite in the right ballpark?
Oh, you're absolutely in the right ballpark. So one thing that Redis has done over the years is focus on the caching side of the business. And they're good for that because you can scale out and leverage RAM. But again, the programming model is a little bit different. And we're finding that we're better for the use cases where you need a lot of parallelism and need a lot of data available at your disposal without having to think about reading data, processing it, and then writing it back out. Because all of that data is just immediately available in our variables, and developers simply continue writing their applications, perhaps in Java or in .NET, and it will treat the system as if it just has a lot of RAM. So we do see Redis a lot in terms of some of the some of the more simpler use cases around caching. But when it gets to more advanced capabilities that leverage in memory, like building advanced custom applications around fraud detection or any type of machine learning inference environment, that's where we really make it simpler for the business.
Okay. And on the subject of sort of parallelization and scaling, do you integrate with things like Kubernetes and Mesos, or does that sort of go against the ethos of performance somewhat? Or?
Yeah, that actually fits quite well with us because simplicity and ease of deployment, ease of maintenance, scalability, elasticity, agility, all of those abilities and all those benefits of modern architectures is something that we were built for. So we absolutely run with Kubernetes and in Docker containers, and a number of our customers are leveraging that. And because we have some of these cloud native capabilities where you can just add a new node, a new instance, and automatically take advantage of that, then it works quite well for us. One of the interesting capabilities of our product is this notion of auto discovery and auto provisioning. So in a lot of distributed environments, you have to pre-install software on a server and set up the configuration. Whereas with our software, if you run two applications on separate servers, they'll broadcast and then auto discover each other and just automatically create a cluster, which greatly simplifies the deployment of additional nodes in a containerized environment. So you just start deploying more applications. They will auto discover if they're configured to auto discover, that is. So you don't always have to have the applications talking to each other, but they will discover each other and then they'll continue to add to each other to build out a bigger cluster. And so that greatly simplifies the DevOps and the overall operations and maintenance of the system.
I was just wondering, I know with Kubernetes, for example, you could set things like memory allocation and stuff like that. And I was just intrigued to know how that might work or not. I guess the whole point of something like Kubernetes and integrating with something like Hazelcast is that you don't have to care too much. You just say, I want this. And if it's available, you get it.
Exactly.
Okay. Now you also have Hazelcast Jet, UltraStream processing framework. Is this something like Kafka or something else?
It is a complement to Kafka. Okay. So if you think about Kafka as the data storage, which is a very rough way of describing what they do, but it's for storing streams. And so we'll read data from Kafka, do the processing, and then deliver it to some output. And that output could be a database, it could be another Kafka topic, it could be a dashboard. So we're about doing some work on the data. And that's why we work quite well with Kafka. And in fact, a lot of our customers use that joint configuration where they'll have Kafka as that initial data source. Okay. And all of the data, feeds into Kafka, and then we read from Kafka to do the processing.
Yeah. Maybe something more comparable to, I'm never sure how well known they are, Flink.
Yeah, absolutely. Yeah. So you could say we're in the same space as
which is now owned by Alibaba, so not a
Correct.
great a big competitor now, unfortunately. And you mentioned here the sort of parallelism with DAGs, directed. I never know how to say the second one. Acyclic graphs. Sort of multiple parallelism, I guess.
Right.
Yeah. Okay. And then finally, you just have this kind of cloud. Is that your? Yeah, it is. It is well, what is it? Yeah, because it's not your own cloud. It's you kind of making tools available onto other clouds. So, is it? What are you adding on to those cloud providers?
Yeah, it's our implementation of IMDG. At least for now. So It's our implementation of IMDG in the cloud. So it's a managed service. So any business out there who is committing to the cloud, building applications and their whole infrastructure in the cloud, and they're looking for performance acceleration, they can turn to us as an add-on into their virtual private cloud and get the in-memory capabilities to add speed and scale. And with all the capabilities around reliability and security, they can make sure that they can continue running an enterprise-grade deployment.
And would this mean that the instances that people use in the cloud version would have to meet specific requirements to make the in-memory possible?
You can kind of think of it the other way in terms of they can pick what instances they want, and then we can take advantage of the memory that are available. So this is trying to simplify the notion of making your applications run faster. there are a lot of engineers out there who are very good at tuning applications and trying to eke out the very most out of their hardware or their virtual instances. But everybody knows that takes a lot of time and it's an exact science, even though there are some very good best practices on how to get there. And using in-memory, especially in the cloud, is a much easier, much more efficient way of squeezing out that extra performance and getting more value out of what you're spending.
I guess I'm just trying to drill down the layers of abstraction here, because I'm kind of thinking that often a lot of instances in the cloud, everything's virtualized, and even the memory may not be always in memory, unless I'm misunderstanding something. I'm just kind of trying to wonder if you lose that performance ever so slightly because of the virtualization, and potentially the shared nature of cloud instances as well. Is there like a kind of minimum spec that you recommend people use, and to not use shared instances and things like that?
Yeah, that's a good question. And so if the thinking is, I have an on-premises cluster and I want to move to the cloud to gain performance, I think that is where you might be disappointed, because you're absolutely right. There is some performance hit as a result of the migration. But what we're seeing as the more important way to think about it is, if you've already committed to the cloud or have applications that you're starting to migrate over, you will not get the same performance that you might have expected, despite knowing the underlying characteristics of your instances. And so you would add on an in-memory technology to help get the speeds that you want. So the starting point is, you have cloud applications. How do you make them run faster?
Okay. And actually, one of the use cases you mentioned here that I wouldn't mind knowing a little bit more about is the Internet of Things use case. And I'm guessing this is for the other side of the Internet of Things, processing the data they're producing, not using IoT devices for in-memory, because I'm guessing they're generally fairly memory limited, but it's more the back end.
Yes, that is correct. So you'll have these devices that a lot of times are very limited in what they do, and they're more about just creating data and then delivering it to some destination. And a lot of the times that destination might be a mini data center, or what people call the edge. So the notion of edge computing is about deploying computer hardware at remote locations, taking data from this remote data source and doing processing remotely from your centralized data center, and then perhaps filtering that data or doing some calculations that are then sent over to your central data center, which is oftentimes the cloud. And then you can do some more larger scale processing from there. So this whole notion of edge to cloud processing is something that we're hearing a lot. And our on-premises, our software technology is great for some of those simplified and limited environments. And then when you tie it together with our cloud managed service, you get that end-to-end processing capability.
You gave me a very nice lead into what I wanted to ask next there. So I've lost track of the date in the current situation, to be honest with you. Okay, 2 weeks ago, you announced this managed service, multi-cloud, cloud-to-edge applications, a couple of the things you just mentioned in your answer there. So if there's any more detail you can give around that product announcement, what have we not mentioned yet that's worth mentioning?
Yeah, some of the capabilities that we've included in our latest offering. So if I can step back, so we've had a cloud offering before. It's known as Cloud Starter. Yeah. And so that's good for anybody who wants to see how in-memory can help them in the cloud. So there are some limitations, and it's a self-service environment, but it's not something that you would necessarily run in a larger scale. So for something that you want to run in a production environment, we announced Hazelcast Cloud Enterprise. And that obviously is for these bigger implementations that require a lot of the capabilities like security and scale that companies want to run for their mission critical or business critical applications in the cloud. Some of the capabilities that are going to be required include things like certification. So SOC 1, SOC 2, PCI certification that we'll handle on behalf of customers, as well as some of the low-level security capabilities around authentication and authorization. And so we provide the capabilities that they otherwise would have to take care of on premises and free them up to focus on some of the other competitive advantage capabilities that they're looking at.
Mm-hmm. I guess looking forward now, what's on the roadmap for the next 6 months to a year or so?
Yeah, a lot of great capabilities around integrating in-memory processing with stream processing are down the road. And we're looking at a lot of ways in which we can further tighten that integration. But so far, a lot of our customers, or a good number of our customers, are using both of our main software technologies together to create these ultra-fast, real-time stream processing applications. But in the area of IMDG itself, there are a number of capabilities that we're adding on to make it look a bit more like a database. And so we'll be making some big announcements later this year around the early Q3 timeframe that simplify the use of an IMDG even further. So again, it'll look more like a database and provide some of the capabilities that you would expect from a database, so that we can now open it up to even more use cases.
Okay. And actually, the question I've been asking a little bit recently, especially when it comes to me adding the article side of this I like to do a bit more of a practical hands-on. And I can see you do have open source versions of IMDG and Jet, which makes sense.
Yep.
What's the differences between the open source version and the commercial versions?
Yeah, so the open source versions have almost all of the capabilities you need to get started and perhaps even run a production environment. And where the enterprise features fill in are about scaling out at a much broader scale, business continuity and security. So one of the capabilities in the business continuity realm is this feature known as WAN replication. So by allowing us to replicate our data in real time to some remote site, you have this disaster recovery capability to make sure that, if there's a site-wide failure, that you have this backup that's ready to go using an active-active topology. And that WAN replication will be important in the cloud, where you might run a cluster on one cloud provider and a mirrored cluster on another cloud provider. And so the whole notion of cloud vendor lock-in is greatly reduced, but you also have the ability to distribute clusters, especially if the data is shared globally, into different geographical regions. And by using our enterprise version, that replication is greatly simplified. So, software handles it all for you.
Cool. Final question. It's always a vague one, but sometimes you never know. Anything we haven't mentioned that you want to make sure is mentioned?
Yeah, I think we've got it all covered. Yeah. I was kind of hinting at that last part about this notion of WAN replication across clouds. Yeah. And by having our managed service that in the cloud, that tends to be this notion of continuity in the cloud tends to be an overlooked issue that people think, well, the cloud provider is going to provide all the continuity I need. So if something fails, they'll make sure that runs. But you have to think about what happens to your software if it's running in an instance and it goes down. So if it's an instance within a single zone, then you might have a distributed system that will easily handle that. But what if the entire zone goes down, which is unlikely, but
it has happened.
It has happened. So if you have some of these applications that are revenue generating and make a lot of money on a per minute basis or even a per second basis, you don't want that to go down at all, because that could represent a lot of lost money. So how do you safeguard against that? And a lot of our customers are using strategies around business continuity on an on-premises standpoint. But as they move to the cloud, they're going to have to think even more about that. And we help reduce that quite a bit. So that's one of the big points around moving to the cloud, just making sure that you not only have some of the performance and the scalability and the elasticity issues that you would expect, but that extra level of reliability that your underlying software will handle is something that people need to consider.
That was my interview with Dale Kim of Hazelcast. Hope you enjoyed that. Actually, quite a few articles came out over the past week or so. I have a write-up of GitHub Satellite. Gone Remote But Not Forgotten was my title for that, which summarizes things up nicely. A roundup of OpenStack Suri, that recent release of OpenStack. A longer article on measuring metrics in open source projects, which was quite interesting to do. I think also I had a Grafana post in there, just probably about actually last episode, but it didn't quite make it in. What else? The other podcast is still in progress. We're recording the second episode of the Board Game Jerk sometime soon, probably in the next few days. I am doing some live streams probably right after this, actually. So they're probably already out by the time you hear this. So go and have a look at those on my YouTube and Twitch channels. You can find the links at christianschiller.com. I think that'll probably do for now. There's been other things I've been kind of chipping away at, but always part-time. It means that every week I have only done like a small bit of progression on them. So yeah, obviously not attending any events anytime soon. I was due to be covering Jamstack Conf, which I still am covering. Covering remote conferences feels kind of odd sometimes. I think mostly because it tends to mean my attention is split. So I don't always focus enough to have much to say, but I'll keep an eye on a few of these. I managed to do the GitHub one, so there might be more. There's quite a few this week. It seems to have gone back to normality where people are scheduling too many conferences at the same time. And in some respects, it's kind of easier because you don't have to book a venue or anything like that. So I think this week there's almost like 3 overlapping events I should be covering. And then again, the time zones being what they are, mean they're not always at a great time. And then I intend to cover them from the videos and you don't go around to it, et cetera, et cetera. Anyway, I'll do what I can. So, yes, until the next time, if you enjoyed the show, please rate, review, share. Please get in touch. I'd love to hear from you. And if you have been, thank you so much for listening.